Okay, good morning, good afternoon, good evening, wherever you are. I'm going to talk briefly today about the refurbished MIRSI at NASA's IRTF. I am David Trilling from Northern Arizona University here in Flagstaff. I'm going to first start with a science motivation. My primary science motivation for this instrument, which I will talk about in a moment, the science that I'm interested in is studying near-Earth objects. These are asteroids whose orbits bring them close to the Earth's orbit. There are many scientific reasons to measure the size and also the albedo of these asteroids. I'm not going to talk about those today. I'm going to really focus more on the instrument. So you have to trust me that there are scientific reasons. But I want to point out that this is difficult to do for a large sample, let's say hundreds of asteroids, except in the mid-infrared. If you have one or two of your favorite asteroids, maybe there's ways we could talk about, but if you want to do a study of a whole population, the only good way to do this is with mid-infrared photometry. And this is a figure designed just to show that this point. So on the bottom is wavelength in microns. And the horizontal axis, the vertical axis is the ratio of the flux at some wavelength to the flux in the V band. And so the point here, I hope you can see my mouse, is just to show that over here at 10 microns or somewhere in that region, the asteroids we're looking at are maybe 10 to 100 times brighter than they are in the V band. Okay, and I've got some reference points here, L and M band, the Ys and Spitzer channels as well. So you can do a survey here at 4.5 microns if you'd like, but you'd really rather be out here at 10 microns if you can. Okay, so let me tell you briefly about MIRSI, which is the mid-infrared spectrometer and imager. MIRSI. The primary operating windows, of course, are the N band from 8 to 13 microns and the Q band at 18 to 25 microns, more or less. MIRSI has been and will again be operated at NASA's IRTF on Maunakea on the big island of Hawaii. Joe Hora at CFA is presently the PI of the instrument, and I am the PI of a MIRSI upgrade, which I'm going to tell you about just very briefly in this talk here. Okay, so just a little history. I don't know everybody who is online in this conference, but presumably some of you have used MIRSI. It operated at IRTF in about 2002 to about 2012. Towards the end of that period, there was limited demand really for the instrument on the telescope, and the cost of liquid helium on Maunakea was going up quite significantly. So MIRSI was placed in hibernation. It was put in a box, and there it sat. In 2015, our team was funded by NASA to upgrade MIRSI and to carry out a near-Earth asteroid survey. So both the instrument project and the science project. First the instrument and then the science with a newly working instrument. So this very high-level description of this upgrade project. The key point was that instead of having liquid helium, the rebuilt MIRSI will have does have a mechanical cryo cooler. And the way RTF works, there are a number of instruments that are mounted all at the same time, and they slide in and out on rails. And so the instruments are more or less always ready to go. Without liquid helium, you can switch instruments, in a matter of minutes during the night. So you could have a new MIRSI opportunity that came up, where you could observe some object with multiple different instruments with just a few minutes in between the instrument, during the instrument changes. As part of this upgrade, there's new readout electronics. Unfortunately, as well, the detector was damaged at the end of MIRSI's previous life. And so we've been doing some work to try to find a replacement detector that would fit within the doer and work and so on. And that has been a little bit of a challenge, but I think we have a good situation in place. Finally, I wanted to mention that as part of this upgrade project, not funded by to us through NASA, but separately from IRTF, is the development and construction of the MIRSI optical camera, which is called MOC. And this is now attached, I'll show you in a moment, attached to the side of MIRSI, and it provides for simultaneous optical and mid-infrared imaging. Or you could be doing spectroscopy with MIRSI and doing optical imaging at the same time. The imager has a number of standard filters. And for a number of science cases, this is actually really a terrific improvement to be able to do the simultaneous optical and the mid-infrared.
5 minutes.
Thank you. Okay, so current status. This is MIRSI on the telescope. Those of you who've been to IRTF might recognize this view. If you haven't, let me briefly tell you what we're looking at. We're basically standing underneath the instrument cube looking up. And so this orange, here's the top ring of IRTF. The silver stuff is the inside of the dome. The yellow is the mount. The blue is at the instrument. Here's the instrument structure holding the instrument cube. And MIRSI is in this red box. Both MIRSI and the optical camera mock are shown in this circle here. So this was about maybe 4 months ago. No, it was about 6 months ago. I should know this because it was basically the last thing that IRTF did before the lockdown on the Big Island. So they put MIRSI on the telescope, but then the observatory was shut down and staff were not permitted there, and so not really much happened. We have a first light image, but we didn't do real engineering at that time. So as I said, first light was achieved, but the sensitivity on sky is actually not as good as we expect and as the previous MIRSI was, and not as good as we hoped, and frankly is not going to be very useful as a science instrument. We think this is an issue with the biases and the control voltages. I am not an electronics engineer, so I don't really understand all the details of that, but we have hired a detector expert who is going to work some miracles. Actually, it sounds like it's well understood, but was just an extra step that we hadn't originally counted on. So hopefully we'll be back on Sky to do engineering in 2021A, which starts in a few months. And so I don't have an exact timeline, but I think a few months timescale we'll be on Sky doing engineering and recommissioning and to carry on our science after that. So, and just to wrap back up with the science, when MIRSI is working on the telescope, we expect to observe several hundred NEOs each year. That's near-Earth objects, these asteroids near the Earth. And with MIRSI and Mach together, we can derive the diameter and the albedo for each. And the third bullet here tells you, we're going to build a size distribution and a compositional distribution. But I also want to emphasize bullet 4 here. I mean, that's my science goal, but all of you have your own science goals. And this is a multi-purpose, it's a general instrument that can be used for many science topics. So here's my summary, and then I'm done. We're upgrading MIRSI to a cryocooler, electronics, and a simultaneous optical imager. Some small but significant technical challenges remain. We'll be back on IRTF hopefully in 2021A in a matter of months, and we'll enable NEO science plus lots of other science.